How did you learn new physics and develop the model on an industry timescale?
I think that it's been a natural, slow evolution as we've gotten more comfortable. That's the way we prefer to do it, is expand a little at a time. The first time that we ever did like complicated multi-phase flows with bubbles and free surfaces, those are always kind of your milestone moments, and you have to be careful, but they're also opportunities.
Welcome to CFD for Industry. I'm Cade Beck, and I'm your host. In today's episode, I'll be interviewing Stewart Bible, who is a co-founder and managing partner at Resolved Analytics. Stewart has been the lead engineer on over 200 simulation projects, and in 2017, he became the first ever recipient of the Siemens Platinum Level STAR-CCM Plus user certification. I hope you enjoy our conversation, and please like, subscribe, and hit the bell so you don't miss an episode.
Thanks, Stewart, for joining today.
Hey, Cade, nice to see you.
Yeah. Let's just jump right into it. Can you give us a brief background of what your first exposure to CFD was and when that happened?
Well, sure. I first learned of CFD when I was an undergraduate. I was taking a thermodynamics course at the University of Kentucky, and the professor there approached me about doing a undergraduate research program, and I started with him. And then within a few months, he introduced me to CFD and the research projects that he was working on. And I ended up going to a master's program with him as my advisor. And we were working on development of subgrid scale models for turbulence modeling. And I got a little bit of exposure to some commercial programs because occasionally we would have commercial companies interested in using his research group to do some commercial work.
Okay. So was it an in-house code that he had you starting on?
Yes, we were developing a Fortran 90 Navier-Stokes solver. And that was in probably like 1998 to like early 2000s. I was working on him.
Okay. Awesome. Very cool. What, if you were to go back now and, right, learning CFD, for me, it wasn't easy. I'm still learning things, right? But if you were to go back now, knowing what you know now, would there be anything that you'd do differently in the learning approach or maybe how you'd tackle learning CFD from the start?
I don't think so. Since I was involved with him, my first introduction was a lot of numerical analysis. And I feel lucky that I wasn't asked to get on a software and start producing simulations before I understood how computers solve equations numerically, what a discretization is, and that connection with the Navier-Stokes equations and the physics of it. I think that intuitive understanding of the connection between our applied CFD and theoretical physics, or if you would just physics, I guess, if you want to call it, and the application of computers has always been very fundamental to the way I approach and the way I've understood CFD. As far as ways I could have, things I could have done at an earlier stage, I think I could ask more questions, rather than implicitly trusting, the software to kind of make some decisions for me, to ask those questions of why are things going on in the background? Why are certain models assumed to be defaults and others not? But just because it's interesting to learn, and I think, improving your understanding and improving the potential accuracy of your simulations, the more questions you ask about what's going on.
Yeah. Great insight. I think one of the best ways I've heard it described is questions are like Velcro. When you ask a question, you're creating a place for the answer to stick better than if you're just like passively receiving it. So that definitely can agree with that. Questions are always good. So what happened after that? You did your master's, went through it with him. What was the next step for you after grad school?
So I did a PhD program for about a year. and taught an undergraduate's fluid course and a lab, and realized that teaching and research were not really what I was as most interested in as I thought I was going to be interested in. So I started looking for an industrial job. I moved here to North Carolina at the same time, and just bulks in my resume to like 100 companies, and of the few that got back to me, with any applicability to that background in CFD, was a startup here in North Carolina that was going to start doing physical scale modeling of power plant operations, all the air pollution control systems that go into power plants. And the founder of that company had been doing that same thing in Europe, but had recently immigrated to the United States. And there was only one other firm doing it in the United States at the time. And he realized the potential of CFD. So his first hire was going to be somebody with a background like mine. So I was their first employee, and then I became manager of that company. And I grew it from the start to like, I think at our apex, we were doing like 2 million service projects where we would still build scale models of these power plant operations to try to improve them, but we would also do a bunch of computational modeling.
Awesome. That's awesome. So what were the things that maybe surprised you about shifting, right? You said, you realized you thought industry would be a better fit for what you really wanted to do. Were there any things that surprised you about maybe the business side of it, right? I imagine in a startup, you were wearing many hats, especially in that role.
No, I was a charitable manager for 15 years, probably. The people aspect, obviously, that was the biggest eye opener, like in terms of dealing with external customers and internally. There's an aspect of interacting with people that you have to get good at. In terms of like dollars and cents business, I took to that kind of naturally. Like business is all spreadsheet calculations of potential revenues and operating costs and capital costs, and making sure that at the end of the day, that last number on the spreadsheet's green. So I took pretty naturally to the business aspect, but definitely the sales and the personnel management was a huge learning curve, because as one of the first and only employees of that company, I did get out there and I had to meet people and to sell our services and to talk us up a little bit. So that took some getting used to.
Yeah.
The thing for me is like, same as it is now with our company being a service provider and helping people solve problems as it was back then. I mean, the problems that we solve today are a little different and maybe a little more fast paced than the projects that we took on back in those days. But at the end of the day, it was a lot the same. After a 6 or 10 week project, it's really nice to hear your customers say, you guys did great. You provided a service that we probably couldn't have gotten elsewhere. We've used other folks for the same thing, and it wasn't as nice of an experience. Or, like you helped us solve this problem that was potentially going to shut us down or was potentially going to lose me my job. And now I've got a promotion for, solving this problem. Like just contributing to those kind of things, really gives me a lot of, satisfaction. Another thing that gives me a lot of satisfaction in that is the turnover of when you're, working through a problem, you've got another one coming along, or maybe you're working through 2 or 3 different ones at the same time. And just the variety of stuff you see is really attractive to me.
Yeah. That's really neat. So I guess let's talk a little bit more. That was was that one called FlowTech? Is that right?
Yeah, FlowTech. Yeah.
So after, and maybe I'm spilling the beans here a little bit, FlowTech got acquired, but can you maybe walk us through the next steps from FlowTech to where you're at now with Resolved Analytics? What happened, in between that and how did you decide to start Resolved Analytics?
Sure. When we were growing FlowTech, really our only people were people who could do CFD and also go out in the lab and take hot wire anemometry readings and lead projects and talk to the engineers on the other side and understand the air pollution control equipment. So mainly like 80% engineers. We had one or two CAD people and one or two physical model builders. But that was the company. It wasn't going to get any bigger because we were really focused on air pollution control. If I'd had the foresight at that time, I would have suggested becoming a more well-rounded CFD company to look into other industries that were starting to use CFD and start marketing the firm as more of a general purpose instead of a air pollution control power generation consulting company. And if we had done that and we had kind of shifted gears there, and that is sort of the attraction, I'm sure that selling the company wouldn't have been a slam dunk, wouldn't have been like the ultimate in conclusion of that company. But as it were, we were kind of limited. And at that point, a lot of the power plants had started to kind of become saturated with this air pollution control equipment. Their projects weren't coming up as fast. Natural gas was starting to take over from coal. And with natural gas, there's just this natural reduction in the amount of air pollution equipment that's needed. So you can see in the long run, we weren't going to get any bigger at that company. And at the same time, we had just a little bit of IP in air pollution control systems that we had developed along the way that became attractive to this NASDAQ listed equipment manufacturer called Fuel Tech. And we had worked with them on various projects. So eventually they, reached out and asked if we'd be interested in an acquisition. So we jumped at that. I became the process engineering manager. So my job was less CFD related from that point on. It was more about designing process equipment and making sure that it got started up and performed according to what we promised the customer. But there were still CFD people from Flowtech that were with Fuel Tech that were doing CFD. But they were doing CFD in a more limited capacity, pretty much only on projects related to Fuel Tech equipment. And over time, that just kind of became so redundant or repetitive that a few of us kind of wished we were back doing a variety of projects. So that's kind of when the idea took hold. It didn't take too long to take hold, like 3 or 4 years into that. I think people were ready for a switch. And at year 5, I think we started Resolved Analytics. I became the first employee. Shortly after, Caleb Treese joined me. And then we have a few other people from that original team on this team here.
Awesome. What surprised you about starting Resolved Analytics? Like you knew you'd kind of had, right? You'd built the CFD team at Flowtech.
Yeah.
Started it. Were there any surprises, or was it pretty much the same thing, different time span?
I was blown away by the opportunity and the reception. And it kind of goes back to what I said. Like if we'd had a foresight to say that there was a market for this kind of stuff earlier, we could have made that transition earlier and we could, be a step ahead of where we are now. But when we decided to jump in, we had modest expectations of making it up to a 3 or 4 person kind of consultancy. And that didn't last very long. Like we were 1 person, 2 people, 3, 4 people very fast. And just the amount of interest that you can garner through a website and through social media is pretty amazing. But we also had pretty good timing for when we were trying to build that up. That's the time when it's getting cheaper. And that's the time when there's a lot of startup companies forming that are trying to compete with those bigger companies. And they know that the bigger companies already have their designs and they've got to do something a little bit better to compete. And so it was just I guess, yeah, the surprising thing to me is the amount of business that's out there for a niche, specialized consulting company at Blue Dynamics.
Yeah. So one question I'm curious on in that is you talk about you like a variety of problems, but your staple was really starting in the air pollution control. How did you one, learn new physics, and then two, develop the model base around delivering new physics on an industry timescale?
That's a great question. For a while, our projects were still mainly and heavily weighted in that industry. We had some of our old customers, but some also new customers. But yeah, I think that it's been a natural, slow evolution as we've gotten more comfortable with the software and with adding multi-physics. That, for example, I think the first thing was chemical reactions and heat transfer. Like those are parts of the air pollution control systems and power generation equipment that we didn't model them back in 2004. 2004, we were just doing constant density gas flow through this air pollution control system. And then we got a little more fancy and added scalar concentrations of the reagents. And then we might have gone into multi-component species and ideal gas and the differences related to the density. And then, a customer from that group might have wanted, well, I've got a heat exchanger. I would like to understand how to improve it a little bit. Can you do the same thing that you're doing here, but for gas liquid heat exchange through a steel? Okay. So now I've added the physics of heat transfer and conjugate heat transfer. And then we get into reactions. And now when somebody calls you from an unrelated chemical reaction problem or an unrelated heat transfer problem, you've kind of got a little bit of background. You got your feet wet with the solver. So you even though you don't know it to the point of being an expert, you kind of know how feasible it is to do certain projects and how much it's going to cost you, how much time it's going to take to do those projects. That's the way we prefer to do it, is expand a little at a time. Jumping into a whole new physics when a customer asks you about it, like the first time that we ever did fluid structure interaction, the first time that we ever did like complicated multi-phase flows with bubbles and free surfaces, those are always kind of your milestone moments. And you have to be careful, but they're also opportunities.
Yeah. So is there maybe a touchstone or a question that you kind of ask to help filter the jobs of, are we going to take it? Are we not? As you get incoming requests?
Yeah, it's very important to match your customer to what you do well. So one of the things that we would not do well is like a PhD level research project where a big company wants to maybe develop new models or wants to understand how theory aligns with the numerical analysis of CFD related to their complicated physics problem, and especially a physics problem that we're not familiar with, like stuff in fuel cells or just things like that that's out of our scope. We automatically would say, doesn't seem like a good fit for us.
Yeah.
We are more of a versus B versus C, provide our customers with advice on how to make something work better from a fluid dynamics perspective. With that, we have a fair amount of knowledge of all of the different aspects of thermal, mechanical, and fluids engineering, but we're by no means a research group. So we're after those customers, and things that we might ask are, what are you trying to do? What problem are you experiencing? What are you trying to get out of the CFD? You'd be surprised at how many people have a vague concept that they would be benefited by CFD. So they come to us and they say, we see your images on your website and we think that we want to do this for our process. But oftentimes they don't know what that means. They don't know that CFD is even like related to the fundamental Navier-Stokes equations, and that you need accurate inputs to provide accurate outputs. And they don't know what output they're after sometimes. So it's those kind of questions. If we can ever get the customer to pin down, it's important to pin them down on like what result is going to make this successful for you. Is it a, kilograms per second throughput to the system, or a power consumption minimization project, or is it a material minimization project? What's going to appeal to your management that this project provided valuable insights? Because if you don't get that, like people spend $5,000-$10,000 and they walk away with nothing that kind of pushes their business forward, they won't be a return customer. And so we're always after that lifetime value of the customer, like somebody who's going to be coming back 5-10 times in their company history. So then that also sometimes filters out. I don't like to filter out the mom and pop companies and single party inventors of things, because like I appreciate that innovator's mindset, but at the same time, they're probably not going to be a return customer. And they often are the most like challenging customers because they take the most development of their process. They may not understand the fluid dynamics of it. And you end up putting a lot into that project and not getting a lot of return value out of it.
Yeah, thanks for describing that as well. Like, in a lot of the things I've been working on lately, that has come up a lot too. And the question that I've come up with that I've started asking more is, what decision are you trying to make that you can't make now? And that what piece of information are you expecting CFD to give you to help you make that decision? Because without narrowing that focus, just as you described, it could go so many different ways. And especially when you're working with different teams, and in this case, your team and your customers, I've just seen that very recently come to the surface many times of really drilling down to where's the business value here? Because like you said, it's not always readily apparent. And sometimes that can be the hardest part of the whole CFD project, huh? Is drilling down what they're really after. So.
Yeah. And as much as it pains me to say it, sometimes a customer has, when you find that, when you identify that question that you're trying to answer, CFD people want to CFD it, right? They automatically say, yeah, we can CFD that. But then if a customer is looking for let's say a pressure drop calculation through a system of pipe, or a way to evaluate how much flow is going to one branch of a piping system versus another, there are easier and cheaper ways to do that we sometimes have to say, we're not going to take your money for this because you should be doing it this way.
Yeah. Yes, precisely. When you've got a hammer, everything looks like a nail, right? And it can definitely get carried away, but it's not sustainable in the business world. Maybe tying this off, what's been the hardest part about running business? Like, are you still in the point day to day where you're in the software, you're producing models, or has a lot of your time shifted the longer you've gone to more workflows or more selling? Or if you can just speak to what's been the most difficult part for you about this.
I still enjoy the simulations. I do get in and especially enjoy branching out to new physics. Okay. There are opportunities for me to do that. I often do it. The most challenging aspect, I think, is encouraging a certain internal culture that if you have a vision for the company, and I think Caleb, my co-founder, and I do, it's putting it into words first, and then it's putting it into practice every day so that your people see you living it, but also like involving everyone in decision making and the balance of, hey, this is a top-down vision combined with, hey, this is a company for everyone to be, a valued participant in a builder of the long-term value of the company. So that for me is always, it's very challenging to pick the people and then practice it, live it on a day-by-day basis so that everything stays in the right direction. There's going to be some ups and downs, like we've made wrong decisions, and then gone back and had to reverse those on avenues that we're pursuing or people that we bring on. But overall, you got to maintain that trajectory. Not like sales and marketing and stuff. That's been pretty seamless for me. Not too much of a challenge. I like that part of it. Haven't had many, challenges around like infrastructure or capitalization of the company or the legal aspects. We've been lucky to steer away from any legal issues. Right now, I think that the hiring market is very difficult. And another thing that makes hiring challenging right now is that as you and I get older, the kids are staying the same age and they're different. They're just different than they were 5 years ago, and they're different than they were 10 years ago, and they're definitely different than they were 20 years ago. So as an older person, I have to like keep my mind fresh and realize that like nobody's the same, and I have to be flexible to the way that other people are built differently. And so you get like taking in all these multicultural aspects and just the environment that recent graduates have grown up in. Like it is a much different world to be a youth today than it was 20 years ago. So I think just that the labor market is tight, and that even if you are able to find a young, talented CFD person, the mindset's a lot different, and you have to develop ways to work together.
Can I push this a little bit? I'm really curious on maybe like a specific example. So one, you said the market's hard right now. Is it hard in the sense of that people are expecting more salary for less experience is what you typically saw historically, because more and more because the demand has increased, right? So if demand has increased for CFD engineers, more people are adopting it. Are you seeing a starting salary be pushed higher than what you would expect? Or is it you're just not seeing the same experience and training that maybe you did historically? We'll start with that one.
It's the former.
Okay.
So I think even first, all engineers across the board, the ones that show the most drive and self-starting, and the ones that went to tough programs and tackled tough subjects, and their resumes demonstrate that, and they took tough internships and they succeeded, or they took a first job and they have accolades from that first job. I think across the board for engineers, chemical engineers, mechanical, those people are in high demand because of the number of startups and just the explosion of product and process innovation that's happening, even in big companies. Like everybody's after that next big thing. And also, engineers are now valued outside of just hard engineering. Now people want engineers to go into consulting gigs at Deloitte or management jobs at, chemical manufacturers. There's a lot of different avenues, and a lot of people are pursuing MBAs. A lot of the talented engineers are pursuing MBAs, maybe even before they get their first job, but oftentimes after like a first job, they go back and get the MBA, and then sky's the limit. It's hard to compete for those people. But secondly, if you have CFD, if you have that little bit of graduate experience of using ANSYS to do something, or STAR-CCM to do something, or your first internship was tutoring in CFD, like those people are in high demand because there hasn't been that many of them historically. And now, like you said, the need is greater than ever.
Yeah.
So it's the salary. Salary goes up and up and up. And now all of a sudden you're paying, I think I would pay a new graduate probably more than I paid myself to be an employee at the company. That's just the way it is.
So with that, I can't remember where I saw the statistic, but This was a few years ago. I think someone took the Fortune 500 companies, and I want to say easily over 50% had an undergrad in engineering of the CEOs of all Fortune 500 companies.
Yeah.
And so certainly that is a logical thinking, the sequential and just
Right.
process.
Going back to what I was saying about our company culture, right? Like we have to be very careful in that hiring process. Like if someone's going to join here, we want them to be a long-term piece of the puzzle. And because it takes 5-10 years to really get good at what we do, from the people management to the technical aspects. And they grow a book of business. They have customer relationships, and we don't want them to bail after 3 or 4 years.
Yeah.
You have to be careful that they don't want those jobs. Like if you want to be a VP at a Cargill or something like that, more power to you, but that's just not a good cultural fit.
Yeah.
Honest. We're going to be a small business, whether we're 5, 10, 20 people, it's probably not going to get much bigger than that.
Yeah.
And we're going to do what we do, fast project turnovers, innovative community of that kind of thing. So it's important to like filter those people out. And so right now where the challenge is, okay, balance this. There's not that many people and they want a lot of money with, I still have to put another filter on that. And I cannot let myself sacrifice the culture of the company just to find somebody in the right pay range that's available.
Yeah. And to make it even more complex, the data is working against you in that mindset. People are changing jobs more and more frequently as time goes on, right? It's rare for someone to stay. So yeah, thanks for speaking to that really complex aspect of, like you said, managing a culture in business. So
yeah. I mean, a company like us could take a different approach. They could take we only hire people who have been doing CFD and this kind of service business for a while. And just treat them like temporary labor, basically. Okay, you want to leave after a year, that's your choice. You want to leave after 2 years, that's your choice. Personally, I prefer more of a family environment for a small business where people are committed to maybe a longer term vision.
yeah, there's definitely lots of different modes and methods. And as you said, people, I think that to me, that's one of the things that I've appreciated more is just people asking good questions up front. And I think that's kind of where we started. One of the lessons that you said you could do more of is it's okay to realize before you pursue with a company that maybe that's not the best fit, right? That you set the expectations. And I don't know if it's a cultural thing or maybe it's just the way I grew up, but I feel like that was a liberating thing when I got to the point of it's okay to just be clear on, no, that's probably not the best fit for me, and just be comfortable saying no. And I'd rather do something else, right? Instead of keeping your options open. We hear that all the time. And the amount of maybe hodgepodge career advice that's out there that really doesn't help people in the long run.
Yeah. I get that, that hesitancy to say no to things. I kind of have the same mindset, but even more, I see it in younger people. They really don't want to say no to things. So they'll, like you say, there's a lot more job jumping. I see a lot more people with 1 year here, 1 year there on their resumes for 5, 6, 7 years in a row.
Yeah. Well, I'd like to ask, what has been the most rewarding technical problem that you feel like you've worked on that resolved analytics? Is there one that really stands out to you of maybe it was a new physics thing that you took on, or what's been the most rewarding problem that you tackled?
I'd say it's, we worked for a sprinkler company and they had an idea to kind of go away from the traditional engineering process that they've been using for 20 or so years. And that process results in like a multi-body sprinkler with a lot of pieces that require a lot of people to assemble in factory. And they wanted a brand new single piece sprinkler. But to do that, you have to open your mind to completely new concepts. And so we were lucky enough to work with a program manager over there who was very innovative and open. So
Hmm.
he was bringing aspects of ideas from biomimetics, like nature-inspired solutions, and believed in the power of computers as kind of like black boxes that you could, if you knew how to do it the right way, just say design an emitter, design a sprinkler, and go. It wasn't that easy. I had to, rein that customer in quite a bit and say we aren't to the point where we can just talk to the computer and ask it to make us a sprinkler. We have to have some inputs, and they still have to be fairly algorithmic. But we use, some AI, if you want to call genetic algorithm optimizations AI, sort of a heuristic type of AI. And we combine that with multi-phase, some water and air. And at that time, STAR-CCM did not have a model for going from the volume of fluid to Lagrangian droplets. And it does now. I think ANSYS has that capability now. But we kind of had to bake our own way, stimulate a volume of fluid, atomization process. But when the droplets got small enough, we would turn those into Lagrangian droplets and watch their trajectories. And so we were able to, over the course of 6 months or a year, use this process, develop the models, validate the models against, laboratory tests that they were doing with prototypes. And eventually it resulted in a really cool product that they're in the process of getting to market.
That's
That
awesome.
that one was really rewarding for me because it was challenging, but doable.
That's awesome. I love what you touched on in the beginning of that sometimes, and I think it's a podcast I listened to recently, the gentleman's name is Tony Ulrich, and he talks about how when we solve problems, we're so quick to jumping to solution space, like thinking we've already clearly defined the problem, that we miss so many innovative opportunities from coming back to really open up the lens of what are we really doing and reframing the problem in a different lens, a different perspective. And I think that's such a nice example of that, of someone who's willing to look at it from a different angle rather than what has historically been done. And that's
and you
exciting.
work in wastewater and water, right?
Yeah.
I think that industry is a perfect example of something that's been done the same way for 20 or 30 years, but
hundreds. Well, at least 100 years.
If you could force yourself to think outside that box.
Yeah.
There are a lot of ways to become more water efficient and energy efficient in those plants.
Absolutely. And we could talk a lot about this. I know Europe is seeing more drivers than the US is seeing in incentivizing that innovation. But yes, absolutely. Absolutely.
It's a huge energy consumer.
Yep.
Greenhouse gas producer.
Yeah. Yep. So Stewart, last question before we close out. What are you most excited about with Resolved Analytics, CFD, the market? Where do you see things going, and what gets you excited about where things are headed?
Oh, yeah, that's a great question. I'm not super excited about anything going on in software. I love what all these small companies are doing with innovation and trying to make more environmentally friendly products and more accessible products. So there's a lot of things I really like that are going on in the industry at large. What I'm super excited about in terms of CFD is that we're living in a really cool time where people are becoming more productive through the use of technologies like artificial intelligence or community-based stuff. There's a lot of recent developments in mentors and experts creating courses for people, and those courses being relatively inexpensive and things that they can consume in a way that people are consuming these days. I think there's a huge opportunity there for people in CFD. And I don't know who's going to do what in the whole field, but I think one of the things that Resolved Analytics is kind of dedicated to contributing at this point is we wanted to develop a community of CFD users that is there for one another. So I think in the traditional, if you're familiar with it, Kate, and I'm sure a lot of your listeners are familiar with it if they're software subscribers, the traditional method is look at a manual, see if it can solve your problem. If you're still having trouble, contact the developer of the software and they'll try to help you. And oftentimes you're talking to somebody that doesn't share your background or your application knowledge and probably is just going to look at the tutorials as well and say, have you checked this tutorial for how to do that? And if they can't answer your problem, if that doesn't get it, then you go to the next level. Well, working with us right now, it's kind of the same thing, but maybe a little bit more personalized. People email us or they text me or whatever, and we try to solve their problems one-on-one. I think what we're trying to innovate is a community where we are available in a more consumable form, like a Slack channel or a Discord channel. All of our people are there, living there every day anyway. We do it as an internal company, so we're on those tools. We could very easily have our CFD community there and be able to answer their questions in real time. But I think even more important for the users of that is that everyone on there is going to be able to see everybody interacting. And so they're going to develop these relationships and networks where they don't have to depend just on us. They can depend on their colleague in a company that's in a related industry down the street, or they can use them to network and build their careers and learn new things. So it's going to be a learning community, but also a helping community. There's going to be some of our training as we develop these kind of online training materials. Those are going to be available to the people of our community. And I'm just really excited to get that going here in the next couple of months and then see it grow. I hope it grows. We're going to try to implement some large language models that we're training for to allow people to ask the LLM questions about CFD or how to do a problem and hopefully have the answer right there for them in Slack that way. So it should be a fun experience. It should be an interesting thing that we're doing there.
Sounds really, really interesting. Yeah, a lot of the research that I've read, I'm curious to see where things go, because one of the things that I've been reading a lot is there's kind of two theories. There's this hive mind, and I felt it in grad school. It was much easier. Your problem was clearly defined, and you knew where you were headed, right? Like you could focus on it and just tunnel deep. But responding to customers and being in a place where you can't just lock yourself in an office and crank on the math or whatever you're doing all day, right? You've got to be available. I've found it difficult to measure the trade-offs between being available and getting information when I need it, but also having the space to think deeply. And because there is a trade-off, right? We know attention residual theory and that stuff and switching tasks and stuff like that. And so I'm hopeful that you can come up with a way that preserves both, because that's something that I have definitely struggled with. I can't just lock myself away, but at the same time, when I am getting too much input, it diffuses my focus. So I'm really excited.
I think that what we're doing actually, it kind of goes to solving that problem, right? Like, yes, we all have so much more to do these days, and we're all getting so much more done that you do have to compartmentalize, and you have to give yourself the 2 or 3 hours a day to get deep into something. Mm-hmm. But you also have to do all of the other things that you're talking about to expand your network and to learn new things. But we want to do those now on our time. Mm-hmm. I think having a community there to answer your question in real time, instead of having to send an email off to Siemens or Ansys and get an answer a few days later, and then go back and forth another few days, like get rid of that filter. And so like people want to consume at their time when it's convenient for them. And I think we're trying to help solve that problem a little bit.
Okay. That's exciting. Very exciting stuff. Wish you all the best, and always good to talk with you, Stewart. Well, thank you so much for the discussion today. Really appreciate it. And
of course, my pleasure.
If someone is interested in getting in touch with you, what's the best way to do that, Stewart? LinkedIn, the webpage?
Either one of those. Visit us on the web. look me up on LinkedIn. I connect with everybody. So, yeah, happy to chat with anyone.
Awesome. Well, thank you.
You're welcome.
Thank you for listening. Really, thank you. What happens next is the most important part of the episode. Pick one thing that you can do in the next day to apply what you learned. Then do that one thing. See you on the next episode.